A lighthouse is 200 yards from a bike path along the edge of a lake. A walkway to the lighthouse is 400 yards long. Find the acute angle between the bike path and the walkway. Let's go ahead and draw what we've got here. So we've got a path that's along the edge of a lake. So here's our lake. I'm really quite a good artist, as you can see here. We've got a lake and we've got a bike path. Here's our bike path, right? Bike path. And the lighthouse is 200 yards from that. So it's going to be like, here. And I'm just going to do the top of the lighthouse there. We're looking at the top of the lighthouse there. It comes down to the ground there. All right, so there's our lighthouse, and that distance there is the 200 yards. There's also a walkway connecting the lighthouse to the walkway, so that'd be something like, this. And we are told that that is 400 yards long. We're trying to find this angle between the bike path and the walkway. That's this angle right here that we're looking for. It is important to note, okay, we have this angle that we don't know. I'll call it theta. We know the side opposite it. This is a right triangle. And we know the hypotenuse, which we know that opposite over hypotenuse is the sine. So we have the sine of this angle is equal to the opposite over the hypotenuse. And, well, that's just 1/2. Okay? And if we think, we've seen this before, okay? There is a triangle where we've got an opposite and we've got a hypotenuse of double that. And this is a special right triangle. Okay? This is a 30, 60, 90 triangle. Okay? So that means that we actually know that the angle, that acute angle, opposite the shorter, is actually 30 degrees. Okay, so that angle theta is 30 degrees, or we could write that as the radian measure. And if you don't remember the radian measure for 30 degrees, as pi over 6, you can multiply that by pi over 180 degrees to get that conversion. That's the angle formed by the bike path and the walkway.